Hi everyone, in this video for grade 9 we have 1.7 which is about compound inequalities on page 31 in the book. In the compound inequalities we mean we have two different inequalities. We solve each one of them, then we will show the result, the solution of them on the number line, and at the end we say this is the final solution for both of them together for these two inequalities that we have. We have AND with OR that we use in between. In AND we solve in a way, and OR we have another way to solve the final solution of the inequalities together. Let's see how we do. The first one, we have this inequality: 4 is less than or equal to x plus 2 less than or equal to 8. We have two different signs, 1, 2 sign of inequalities. In the others we had one. In the other lessons we had only one inequality. It was just like that much. We had one sign, but now there are two. When there are two and there is nothing in between, we make it two parts. The two parts, always the one in the middle, we give it to both of the sides, like we deal as like that. 4 is less than or equal to x plus 2. At first we write this one. 4 is less than or equal to x plus 2. The one which is between, we will give it to both of them. And always when they are all together, there is nothing between, we write and x plus 2 is less than or equal to 8. X plus 2 less than or equal to 8. The one which is in the middle, once we use it with this one, once we use with the other one. That much. Now we solve each one of them individually. We solve this one, we show on the line, we show the other one, we solve it and we show on the line. It would be just 4 minus 2 is less than or equal to x. 4 minus 2 is 2, less than or equal to x. 2 less than or equal to x. Done for the first part. The other part, which is, let's do it in black. X is less than or equal to 8 minus 2. We just moved plus 2 to the other side. The same as we moved these two to the other side. X is less than or equal to 6, and this is the second part. Now we did each one of the parts of the inequality we solved. Now we have these numbers 6 and 2. 6 and 2, we must have both of them on the line. I gave you some extra lines if you needed to show individually, but normally we all show on the one line that is given. One line would be given. If you want to show those numbers less than 6 in one and those numbers which are less than those numbers which are greater than 2, you can show individually, but now we do it on one. But in this line we must have both of the numbers 2 and 6. So we can start writing the numbers from 1, 2, 3, 4, 5, 6, 7, 8. Now we have both of them. We have 2 and we have 6. For the first part, 2, and we fill the circle. 2 less than x means 2 less than those numbers. You can check a number for yourself, put 4. 2 is less than 4, yes, you go to the side which you have 4. But in this one, in the compound inequality, don't show on the line at first, because this is only the solution for this one. Now we show the solution for the black one, which is x is less than 6. Let's show 6 and fill the circle. Those numbers less than or equal to 6, we know this side would be. This side is the solution for this one, and this blue is for the other one. Now in AND, always when the question is AND, you show the solution on the line, only the part which is solution for both of them. the one which is between both of them, which is for both of them. Which part is for both of them? If you check, for example, between these two, you see that they are solution for that and they are for that. Only this part is between. If you check this side, for example, if I check that, I see that this is not a part of the solution for the blue one. The blue didn't come here. So this is not a part for the blue one. We cannot show that. And if I check this one, I see this is not the solution for the black one. The black, there is no black in this side. So I cannot show that when the question is AND. In AND, you only show the part which is common solution for both of the parts. This is about the first example. And then for the next one, we do the same. It is AND again, which is -5 is less than or equal to 2x plus 3, less than or equal to 9. We make it two parts. -5 is less than or equal to 2x plus 3, and always we write AND when this is all together, then 2x plus 3 less than or equal to 9, less than or equal to 9. Now we solve it. 3 to the other side, it will be -5 minus 3 less than or equal to 2x. -8 is less than or equal to 2x. Because we have 2x, we can divide by 2. Divide by 2. Because we divided by a negative number, we don't change the sign of the inequality, we put it the same. -4 is less than x. The other part we do 2x is less than or equal to 9 minus 3. 2x is less than or equal to 6. Because we have 2, we divide by 2. X is less than or equal to 3. Now we must have these two numbers on the line. We must have these two numbers on the line to show the solution set. Always in AND we check for the part which is common for both of them. Because we have -4, we must have it on the line. We say -4, -3, -2, -1, 0, 1, 2, 3, 4. Now we have 3, we have -4 as well. We show each one of them. For the blue one, -4, we fill the circle, it's a part of the solution. -4 is less than x. It means -4 is less than these numbers. This is the solution for the first one. The other one, x is less than 3. We show 3, we fill the circle, and we know these numbers is less than 3. Now we only show the part which is for both of them, between both of the lines. If you see this line, this side, from the 4, 5, there is no black solution. In the other part, we don't have blue solution, so only this part is between both of them. So this is the solution for the inequality that we have, only this part. In the exam, in the questions, we need only that much. We showed them to clarify, to show that which part will be the solution for both. Then we show that the final result for both of them is only this part. That's about the examples about AND. Now we solve two examples about OR. Then for the examples about OR, in OR it's already given. It tells you in between or. Directly you start solving this one alone and this one alone until you do. For this one, negative 4 plus a is greater than 1. You can directly solve. Negative 4 to the other side, it will be positive a is greater than 1 plus 4. A is greater than 5. The other part, negative 4 plus a is less than negative 3. Positive a is less than negative 3 plus 4. We move to the other side. A is less than positive 1. Now these are the two solutions that we have. For the number line, we show these two. We must have these two numbers, 1 and 5. So we can start from 0, 1, 2, 3, 4, 5, and 6. Now we have both of the numbers. We show the blue one, which is 5. We don't fill the circle itself. It's not a part of the solution because only those numbers greater than 5, not 5 itself. A is greater than 5. Which side are those numbers which are greater than 5? This side. A is less than 1. We show the part of the black one. A is less than 1. Which numbers are less than 1? This side. Now we see there is no part which is common for both of them. But in OR, when the question is about OR, whatever you have in the solution, you directly show. You don't need common part. In OR, we don't need common part. All those which are shown directly, they are a part of the final result, final solution for the inequality. It means this side is solution because it's solution for one, at least for one of them. And this side is solution for this part. These two are solutions. In OR, you don't focus on the common part. You don't need it. Directly, whatever you have in the solutions, you show all of them. But in AND, you check. You will see what is only common between both of them, common for both of them. You show only the part which is common. The next question, which is 2x is less than or equal to 6. Let's solve each one of them, which is 2x is less than or equal to 6 because we have 2x. We can divide by 2, would be x is less than or equal to 3. The other one, 3x is greater than 12, divide by 3, x is greater than 4. We have these two. We must have 3 and 4 on the line. We can say 0, 1, 2, 3, 4, 5, 6. We show this one, which is blue, 3, and we fill it. We have equal with it. Those numbers less than 3. Numbers less than 3. And 4, we show 4. Numbers greater than 4, we show those numbers greater than 4, 5, 6, 7, 8. Because the question is OR, we don't need common part directly. What we have, we show all. This is a part of the solution for the blue one, and this is a part of the solution for the black one. We don't need common part. That's all about compound inequalities. How you do? You solve each one of them individually. You show the numbers on the line. You show each individual solution for the inequalities. Then in AND, you only show the common part between the lines. For OR, you don't look at the common part. You show all the results. Thanks for watching. Have a good day.